Hello, in this video we will see matrix operations. So let's start with creation of two matrix so we can use them to perform basic operations. We'll create the first matrix M1 using the matrix function, and we will give the argument as sequence 5 through 8, and we can define the rows and columns by using C function. Let's give it as 2 by 2, where we have number of rows equals 2 and number of columns equals 2. Define another matrix object M2 using matrix function, and we will use sequence function 1 to 8 with a difference of 2, and again define the number of rows and columns using the C function, and we will give 2 by 2. Let's print matrix M1, and here we have matrix M2, and we will see both the matrices are 2 by 2 matrices. Let's start with a basic addition operation. Say I want to add the two matrices. What I would do is I would put the expression as M1 plus M2, and so what it would do is it would do element wise addition. So the first element of this matrix or the element which is at the position 1 and 1 would be added to the element of the other matrix at the position 1 and 1. So you see it's 6, 5 plus 1, 6 plus 3, 9. So it's element wise addition. I can add a scalar value to the matrix. So if I want to add, say, 10 to matrix M1, I can do that by using just a simple addition operator here, and it would do element wise addition. It would add 10 scalar value 10 to each of the elements of the matrix M1. In the similar fashion, we can do subtraction M1 minus M2. We can do division M1 divided by M2, and we will see element wise division. We can also do multiplication M1 into M2. Okay, the key here is when we use the multiplication or asterisk symbol here, it does element wise multiplication. So it would take the first element here and multiply with the first element of the other matrix. It's not the actual matrix multiplication. In order to do the actual matrix multiplication, what we can do is we will have the first matrix, the percent sign, asterisk, percent sign, followed by another matrix, and this time we will get the actual matrix multiplication. What else? We can find a transpose on a matrix. So let's clear the screen. Okay, so once again we had M1 as the matrix, as this matrix, we had M2 as this, and we want to find the transpose of M1. So we can do it by using the T function on M1, and you see that 5, 7 and the matrix M1 is now transposed. We can also do the inverse using the solve function on M1, and it will calculate the inverse of the matrix. We can generate the diagonal matrix by using diag and define the dimension like 3 by 3. So if we give here 3, obviously the diagonal matrix is symmetric, so it should be either 2 by 2 or 3 by 3, cannot be 2 by 3. So we see here that we got the 3 by 3 um, diagonal matrix. We can also obtain the eigen values or eigen matrix on M1. Suppose we want to find the eigen values and vector for M1. We can use the eigen function on M1 and we will get the value as well as the vector. Other things we can other operations would be, suppose we want to find the sum of all the elements of the matrix. So suppose we want the sum of all the elements of matrix M2. We can do it by using the sum function on M2. We can find the sum of the, let me first get the matrix M2 here. Okay, we are interested to calculate the sum of the rows, sum of the columns, and we can do that by using the row sums on M2. So it will sum up the elements in the rows, and in this case it is 6. The second row would sum to 10 and we got 10. Similarly, we can do col sums to find the sum of columns on M2, and we saw the sum of the first column is 4, the sum of the second column is 12. We can also find the means of rows and columns. So we can use row means function on M2. It will calculate the mean of the rows. And to calculate the column means, we can use col means function and say we call it on M2. We get the means of the columns. And another thing we can do is say we have a vector v1, say 1 through a sequence of 10 elements. It's a vector, and I want to convert this vector to matrix, and the exclusive conversion we can do by using as dot matrix function, and we call as dot matrix function on v1, and the result would be a matrix. A v1 vector will be converted into a matrix of sequence of elements, and so the resultant is a matrix.